Good afternoon. I am Mr. Ish. You're joining me for this 2-question video here on speed, distance, and time. You know, these are basically word problems and they show up everywhere. We'll start here with question number 1 and I'm going to read it out. At 9 a.m. a car leaves Port City heading west at 55 miles per hour. 2 hours later, another car leaves the same point heading in the same direction west at 75 miles per hour. At what time will this second car overtake the first car? We know the second car is obviously traveling faster than the first car, but the first car has a 2-hour head start. How can you go about doing this? Start with a diagram. We're starting here at 9 a.m. We have car, we'll call the first car car A, the second car car B. They're both heading the same city and going in the same direction. East and west, it doesn't really matter. We know that car A is heading 55 miles per hour and it left at a certain time, we'll call that X. We know car B is going at 75 miles per hour and it started at a time 2 hours later, so you can just say X minus 2. At what time will the second car overtake the first car? You know, obviously the first car is constantly moving, so it's going to take quite a bit of a time with this car being 2 hours behind, even though it's 20 miles per hour faster, because this first car is still moving as it's trying to catch up. And we know at the time that it catches up to that first car, this here is a very fundamental part of this whole problem. The distance of both cars having traveled will be equal, because that's the point where the overtaking will occur. So that right there leads you to your equation. The first car is 55x. It's always speed times time equals distance, right? ST is equal to D. Speed times time equals distance. So the first car, 55x, is equal to the second car, 75x minus 2. And you just solve it out. 55x is equal to 75x minus 150. You can take this on the other side. You have minus 20x is equal to minus 150. And x is equal to 150 divided by 20. The minuses cancel out. You get 7.5. And we know that 7.5 hours. But the question is really asking at what time. So if we started here at 9 a.m., you just have to add 7.5 hours to 9 a.m. and you can just count 9 to 10, 11, 12, 1, 2, 3, 4. At 4:30 p.m., the second car will catch up to the first car. Now, if there was a second part to this question, what will be the distance at which that occurs? The distance is easy. You just put this value right here in any of these equations. We can put it right here, 55 times 7.5. The distance at the takeover point or the catch-up point will be 412.5 miles. And that's where this wonderful event is going to occur. So this question has been completed. The second question of this video here should not be too hard, and let's go for it. A car drives 4 hours at 59 miles per hour to city Y. We don't care what the city Y is, but it's leaving home and it's heading for the city Y. And it takes 4 hours during that trip at 59 miles per hour. Then it stops there for a 4-hour break. Then it heads back home in 3 hours at 72 miles per hour. What was the average speed of the car? Essentially, you're going from this start to this trip end point, and it took 4 hours, right? And it was driving at 59 miles per hour. And then it stopped there for 4 hours and it heads back. But it heads back in 3 hours and it drives at 72 miles per hour. And you know, this is just a hypothetical question. Here it takes a little break for 4 hours. Now this part right here, the 4 hours, is designed to trick the student because it has no relevance to the question at all. It doesn't matter if it stayed here for 40 hours, let alone 4 hours. It doesn't matter. The average speed of the car during the trip is only when it's moving, and this is the only part you look at. How are you going to determine the average speed of the car? You do the total distance, right, traveled over the total time. And that'll give you the speed of the car average. Because you know, if D is equal to ST, then speed is always equal to D over T. You have to calculate the total distance and divide that by the total time. We know the total distance. Distance is always speed times time. For the total distance, you can just do 4 times 59 because that's its time and the speed going. Add to that 3 times 72. That's on its return back, and divide that by the total number of hours, which was 4 plus 3, 7. You just have to do this simple arithmetic and you'll have your answer. We'll do it and we'll post the answer right over here. And the average speed will be 64.57, but I'm going to round that up to 64.6 miles per hour. And that right there is our answer. You can say the average speed and symbolize it that way. And with that, we end this video over here on speed, distance, and time word problems, a very common topic in any type of exam. Stay tuned. Thank you for watching. Have a nice day.